Hello friends, so welcome to lecture number 4 for the chapter number 5 combustion in SI engines. So in previous 3 lectures we studied the stages of combustion, ignition lag, factors affecting flame propagation and factors affecting flame speed, abnormal combustion or knocking, auto ignition, pre-ignition, influence of engine design and operating variables on knocking, and octane number. Now today's lecture will discuss HUCR, requirements of combustion chambers of SI engines and its types, and MCQs that I'll share on the Google Classroom. So let's discuss the HUCR, that is known as the highest useful compression ratio. So as we know that the resistance to knocking is an important property of fuel for SI engine. Resistance to knocking is an important characteristics for SI engine. So these fuels available for SI engine, they are differ widely in their ability to resist the knocking. Means different fuels having the different that knocking, that resistance characteristics, and they are widely available. They are widely available, and that will be depends upon the various factors like chemical composition or chemical properties of fuel, air fuel ratio, ignition timing, engine speed, shape of the combustion chamber, how it going to affect the knock in the engine. So likewise the different parameters are to be considered so that it will avoid the knocking, it will resist the knocking. So in that previous lecture we discussed the octane number or fuel rating. That is one of the satisfactory method nowadays it is to be used for comparing the anti-knock qualities of various fuels. To compare the anti-knock quality of the various fuels, this octane number, that rating is to be used. So in the earlier days the HUCR rating is to be used for the fuel that is used for the SI engine. So in HUCR, in development of SI engine, it is desirable to use the highest compression ratio. It is desirable to use the highest compression ratio engine because it will give us the higher thermal efficiency. It will give us the higher power output. So maximum compression ratio means maximum thermal efficiency, maximum power output. But as we know that the maximum compression ratio for any SI engine is limited by its tendency to knock. And because of that previously the rating of SI engine was based on the highest useful compression ratio. So in earlier days the rating of SI engine is based on this compression ratio that could be employed in given engine under the given set of condition. So how to find out the HUCR? How to find out the HUCR of any particular SI engine? So to find the HUCR, the compression ratio of that particular engine is increased till the knocking becomes audible. Till the knocking becomes audible under the specific set of conditions. Under the specific set of conditions. Under which the fuel used, under which the shape of the combustion chamber, under which the speed, ignition speed, under which the spark timing, all that are kept at the specific conditions, at given specific set of conditions. And during which we are going to increase the compression ratio till the knocking becomes audible. When knocking becomes audible, at which compression ratio, that will indicate the compression ratio for that fuel used for that particular engine. So the measurement of this HUCR is done on Ricardo E6 variable compression ratio, VCR engine, variable compression ratio. So in this table you observe the typical values for different fuel is to be mentioned. Typical values of compression ratio is to be mentioned. For example, normal heptane is having the highest useful compression ratio 3.75. Means if you are using the normal heptane fuel in SI engine, then compression ratio is limited to the 3.75. If the compression ratio is 4, what happens? If compression is 3.8, what happens? Your engine tends to knock. So at 3.75 the detonation or knocking becomes audible. That's why it is a 3.75, its highest useful compression ratio. Beyond 3.75, the engine becomes the knocking, engine goes to the detonation and it becomes the audible noise. It creates the noise and that abrupt pressure pulses, as we have discussed in knocking. Whatever the consequences are there, that should be happening in that case. Second, cyclohexane, its highest useful compression ratio is 8.2, isooctane 10.96, benzene 14.6, toluene 15. So like these fuels having its highest useful compression ratios. So highest useful compression ratio, that is used in earlier days, which will give us how much that compression ratio for the particular engine under particular set of conditions. That is a concept of the HUCR. Now we will discuss the fuel additives. So the compounds called additives or dopes are used to improve the combustion performance of fuel. So additives are used to improve the performance of fuels. So the main combustion problems that arise when operating conditions or operating that parameters becomes the severe or unfavorable and tends to knock or ignition, right, pre-ignition or auto-ignition. So these combustion problems can be tackled by different methods, by alternative methods, such as improve the combustion chamber design, such as improve the different parameters like air fuel ratio, quality of fuel, chemical combination, chemical properties of fuel, retard the spark, like various that alternative that methods are to be used. One of the method is to improve the fuel quality by using the different fuel additives or dopes. Means by adding such a fuel additives or dopes into the fuel, it will improve the combustion performance of fuel. So what are the different requirements of additives? That is in general requirements. It should be a knock resistance. It should be soluble in fuel under all conditions. It should be stable in storage. No any adverse effect on the fuel stability. You should be in a liquid phase at normal temperature and volatile to give the rapid vaporization in manifold. It must not produce the harmful deposits. Likewise, the different requirements we expect from the fuel additives. So there are different that additives are there. Anti-knock additives, so that will avoid the knocking. It will resist the knocking. So such anti-knock additives, example tetraethyl lead, tetramethyl lead, toluene, isooctane, ferrocene. Likewise, the different anti-knock additives are to be used, which is used to resist the knocking. Antioxidants to inhibit the oxidation of other molecules. For example, ethylene diamine, butylated hydroxytoluene. Like antioxidants are to be also added. Oxygenates to reduce the carbon monoxide, to reduce the soot particles in the exhaust due to the burning of fuel. For example, different types of alcohols, methanol, ethanol, N-butanol, ether likes methyl tetrabutyl ether, tertiary amyl methyl ether, lead scavenger. In earlier days of your vehicle, such a leaded gasoline is to be used. Now we use the unleaded gasoline. So this leaded scavenger is used with the leaded gasoline. So it again, to scavengers in chemistry is a chemical substance. It is added to the mixture to remove or deactivate the impurities and unwanted reactions. For example, oxygen, like lead scavengers are to be used. So by adding such additives, we can get the better performance of the. I will see the combustion chambers. You see the combustion chamber. So the design of combustion chamber has an important influence upon the engine performance. It having the great influence on the engine performance at knock properties and its knock properties. So the design of combustion chamber involves shape of combustion chamber, location of spark plug, deposition of the inlet and exhaust valve. Means that will indicates the design of combustion chamber. Shape of chamber, location of spark plug, exhaust valve, inlet valve location. Because of importance of combustion chamber design, it has been subject to considerable amount of research and development. Means different research and development is to be going on in the field of combustion chamber design. It is very much that important because it highly influence on the engine performance and knocking. So in last 50 years there is so many research is to be done in this particular area of the combustion chamber design, and because of that it results in rising the compression ratio for SI engine from 4:1 to the 11:1. Getting, so in earlier days SI engine having the low compression ratio, it is 4:1, but as design that research and development is to be done in this particular area, it is successful to use the SI engine with highest compression ratio. It is from 8:1 to the 11:1. So in present times such a combustion chamber design are available. So the basic requirements for good combustion chamber are higher power output. You should provide the higher power output, means how we get the higher power output? By high compression ratio, small amount of excess air, no dead pockets of air, optimum degree of turbulence, high volumetric efficiency. By using such that methods we get the high power output. Then high thermal efficiency and low specific fuel consumption. How will get the high thermal efficiency? So reduce the heat losses, good scavenging of exhaust gases, good swirl flow in the chamber, compact combustion chamber. Likewise different methods are there. Then smooth engine operation. How will get the smooth engine operation? So by moderate pressure rise, then avoid the knocking tendency, compact design, proper location of spark plug and exhaust valve. Getting, so by that way we get the smooth engine operation. Then how will get the that exhaust, reduce the exhaust pollutants? So exhaust pollutants again were avoids by the proper quality of fuel, proper chemical properties of the fuel, by which we are avoid the exhaust pollutants as well as the exhaust that emissions. Getting, so the types of the combustion chambers. So the few representative types of combustion chamber here we are going to discuss. T head combustion chamber, L head combustion chamber, I head or overhead wall combustion chamber, F head combustion chamber. So it may be note that these chambers are designed to obtain the objectives, namely high combustion rate, high surface to volume ratio. Rather also it has to locate the spark plug at the center. These are the objectives for this type of combustion chambers. So first we will discuss the T head combustion chamber. So see the figure. So its figure is having the shape T head. So these combustion chambers were used the earlier stage of engines, means at earlier stage. So when first motor or engine is to be developed by Ford Motor Corporation in 1908. So this design was introduced by this company Ford Motor. So earlier stage of development such a design is to be used. So this design has the different disadvantages. For example, it requires the two camshafts. As we know that inlet valve and exhaust valve both are located at the side of the engine. Means to actuate this valve, inlet and exhaust valve separately, we require the two camshafts. Getting, so that is a one disadvantage. Then it also having very prone to detonation. Means detonation is suspectable in this case. It is prone to detonation. Easily it going to detonate the engine. So there was violent detonation even with the compression ratio 4. Means if we are going to use such chamber, then compression ratio is limited to the 4. Getting, so because of that average octane, so during that period also the fuel available having the octane number 40 to 50. That is also one that limitation during that earlier days. As well as in this chamber, the distance for flame travel across the combustion chamber also more. Getting, why it is prone to detonation? Because as flame travel distance is to be increased, means the time factor. Getting, means time increases for the flame travel, that tends to engine to the knocking. That is the important that disadvantage with the T head combustion chamber. So in earlier days such kind of that combustion chambers are to be used with the. Then L head type combustion chamber. So it is again the modification in the T head combustion chamber. So it provides the two valves, that is exhaust valve, inlet valve, on the same side of engine, and again these valves are again operated through the single camshaft. Getting, so that is the one benefit of this type of that combustion chamber, this type of that combustion chamber. Again this is introduced by the Ford motor between 1910 to 30. Between 1910 to 30, again there are different developments they are added with such kind of that combustion chambers. Getting, so that is the one important advantage, is that the combustion chamber are easy to lubricate. Getting, or that is very easy to lubricate the valve mechanism and remove the cylinder head without disturbing the valve train. So here in that case you can easily remove the cylinder head without disturbing the valve train, and too easily you can lubricate the valve mechanism. That is the main important that advantage with the system. Getting, again the disadvantage of the design is that airflow has to take the angular turn, as the inlet valve is at the side, so it has to take the angular turn to enter and exit the cylinder. During the exit also exhaust gases has to take the angular turn for the exhaust. So this causes the loss of velocity and turbulence, resulting in slower combustion. Because of that the initial turbulence is lower, and because of that it causes the loss of velocity, and because of that the combustion is slower. As well as surface to volume ratio is more, therefore more heat loss, as surface to volume means surface area is more than the volume. Because of that what happens, more heat is to be goes to the surface, and that way the heat loss is more, means thermal efficiency is lower in that case. Getting, also it is having prone to detonation, because again the flame travel distance is more, time factor is again here, and because of that it again causes the detonation. As well as the low turbulence is again the, as turbulence is lower, why? Because the whatever the at the inlet, whatever the air fuel ratio is enters inside the engine cylinder, it has to take the angular turn 2 times. Getting, and because of that it creates the low turbulence, and as we know that turbulence is directly proportional to the that turbulence directly affected with the detonation or knocking. In that way the knocking is easily at with the lower turbulence, it occurs at the lower turbulence. Third one, I head combustion or overhead combustion chamber. So this is also called overhead valve combustion chamber. So in this case both valves are located on the cylinder head. If you see the figure, both valves are located in the cylinder head. So the advantage of such combustion chambers are less heat loss. Heat loss is less due to lower surface area. Surface area is less in this case. As in previous two cases, T head, L head, the surface to volume ratio is more. So in this case surface to volume ratio is less, and as surface to volume ratio is less means the heat loss is lower, and as heat loss is lower means we can utilize this heat loss, lower heat loss in the thermal efficiency, increase in the thermal efficiency. So less heat loss due to lower surface area, because of the thermal efficiency is more, as well as less flame travel distance is lower, so knocking tendency also lower. Getting, knocking tendency also lower. Volumetric efficiency also more, as the inlet valve is located in the that cylinder head itself, means again the volumetric efficiency is more, means there is no air fuel ratio is not going to take any turn, so directly it enters in the combustion chamber, so volumetric efficiency is more. Getting, also easier to manufacture and low cost, that is the main benefit. So since 1950 and so mostly till date, such that overhead or I head combustion chambers are in use. Getting, next, F head combustion chambers. So this is a combination of L head and T head. If you see, this is a combination or compromise between L head and I head. sorry, which is I head, not T head. So this design is compromised between L head and I head that combustion chambers. So how it is compromised? For example, L head means in this case inlet valve is at the side. It is located at the side, and I head exhaust valve in the cylinder head. So in that way it is a compromise or combination of L head and I head combustion chambers, because one valve is in the cylinder head and other is in the cylinder itself. So two camshafts are required. Again here two camshafts are required to actuate the inlet and exhaust valve, which is a disadvantage. So its a disadvantage is high volumetric efficiency, maximum compression ratio, high thermal efficiency. Also it can operate even at linear air fuel ratio without misfiring. Drawback: designing complex mechanism for operation of valves and expensive special special shaped piston. That is a disadvantage. Again, such that type of the F head combustion chambers are mostly used by the rover company. They are till date is used for the rover as well as the village jeep. Rover, that is a Range Rover, Jeep companies also there. So they are going to be use such a designs in their vehicles. So such a F-shaped combustion chamber that is available in the various types of that engine that is used by the rover company and the Jeep company. Getting so such that designs are available. So here in the figure it shows that the F head used by rover company, also F head used by the village company also. Thank you. So this is the end of this chapter, that is a combustion SI engine. Hope all of you are understand the different contents we discuss in the chapter. So you can also read the notes carefully as well as listen the lecture carefully. Then it is very easy to get the concept about the various contents in the chapter. Thank you.